Got home and watched the video on YouTube and did the.
That's wonderful, because that will be easier. I just know that it was a very busy weekend and maybe not everybody had time for it, but that'll keep you up a little bit better. All right, so A1 would be your first term, A2 is your second term, A to the N is your nth term, A sub n minus 1 is the term before that. So that's just a little recap of some stuff that we have done before. So this first situation is one like we could have done on Friday. So it's just going to be a basic recursive formula. So I'm going to write a recursive formula for the following situation. Tanya ingests 400 milligrams of ibuprofen. Every 4 hours, her body metabolizes 67% of the medicine that was in her body at the beginning of the 4-hour period. Write a recursive equation that represents the amount of ibuprofen in Tanya's body at the end of each 4-hour period. Okay, so this is, I did not particularly research effects of ibuprofen on the body and know that 67% metabolizes. What I do know is most of the time you're going to take a 400 milligram dose, and it tells you can take it every 4 hours if you need to. All right, so that's why I picked the 4-hour period, because we're going to use that for something in a moment. I made up the rest of this stuff. I do not know how accurate it is, but I do know that this pattern is how medicine works in your body. So, and there would be a big difference just between people. So, like, if we gave, Maggie 400 milligrams of ibuprofen versus Coach Wood 400 milligrams of ibuprofen, right? They're not going to be exactly the same because their bodies are not exactly the same. And Coach Wood is 2 or 3 times bigger than Maggie is. So, this is, it'd have to be highly specified. But this is the way medicine is going to work in your body. So your body, as you ingest something, whatever, ibuprofen, is that mostly your liver or your kidneys? One of them affects liver. Is it liver for ibuprofen? And then kidneys, Tylenol is rougher on, right? I think. One of the other. I'm no professional here. Do not take this as professional medical advice, and a disclaimer like it goes across the bottom. So what happens is, like, you take it, it gets into your bloodstream, you start to feel a little better, and then your liver, probably some kidneys a little bit there too, but your body is processing it and it's filtering it out, the ibuprofen, right? And then, so every 4 hours it's using up some of that, or really, you can go like every hour. You'd have to change this number here, but your body is using up a percentage. A little bit of it remains. Right, so we're going to see what happens here. It's taking out a percent, because if you think about, we used to do this thing in Math 1 that's with the oil spill, and like if you were trying to clean up an oil spill, you have oil and water, and it's kind of like all mixed together. They kind of separate, but so you can kind of skim off the top some. But whenever you're trying to clean it up, you're going to get some water in with the oil. You're not going to be able to just pick up oil, because you want to leave the good water and only take the oil. But what you're going to have to do is you're going to have to get a bunch of liquid out of the ocean, run it through whatever filters or whatever you're doing to pull the oil out of it, and then you're putting some back. Those filters are not going to get 100% of the oil. Some of it is going to go back in, but the percent is being decreased each time. Your liver and your kidneys and all of the parts of your body that filter out things, it's similar. You have something in your bloodstream and it is filtering that out, but part remains, right? So whenever you are metabolizing 67% of that medicine, what does that mean? Does that mean we still have 67% left, or 67% is gone? If you metabolize something. Metabolizing is going to mean that your body is using it up. So we actually are not going to use 67%, right? We're going to use it to find something. But we don't want that in our formula. If So 67% is gone. What part remains? 33% remains. So every 4 hours, basically you got a third of the ibuprofen left, and then you'll have a third of that. So this is what that's going to look like. At 0 hours, how much are we going to have in our, she will have 400 milligrams in her system. We will ignore the fact that it's going to take a minute for it to get into her system as you ingest it. But 400 milligrams. So after 4 hours, how can we figure out how much she would have left? If 33% remains, 33% of 400, which to do that, all we've got to do is do 0.33 times 400, and that will give us 132. Okay, so at 4 hours, she's got 132 milligrams of ibuprofen still in her system, right? So now her body is going to metabolize again, right? So at the end of 8 hours, and I'm going up by 4 hour increments because they told us to do so. Here, 33% of that will be left. So if we multiply that by 0.33, so 132 times 0.33, now we got 43.56. And so now she's got 43.56 milligrams circulating through her system. Her body's going to continue to process that. We're going to take away another third. And so if I multiply that, here I'll get 14.3748. At this point, is Tanya feeling any of the effects of the ibuprofen? Probably not at all, right? We're like down to very small amounts. And this is going to continue. Theoretically, mathematically, is it ever going to be 0? Technically, it never gets to 0. Theoretically. Now, as far as like what really matters for your body, it'll be back down to 0. But this is going to, just continue that pattern. It's just going to keep going down and down and down and down until you just got like teeny tiny amounts. This is why, now ibuprofen, of course, is not a restricted substance. You can take ibuprofen and it's fine. But this is why, if you were to choose a different substance to ingest, perhaps one that is not legal for you to ingest, in whatever way you may choose to ingest it, and you did that on the weekend, and then you got called for drug testing 2 weeks later, this is why they can still detect it. Because even though it has been 2 weeks since you did whatever it was that you did, and you have long since, had it out of your system to where like you're not feeling the effects of it. You're not walking around for the next 2 weeks high as a kite. But if you get picked for drug testing and you go pee in the cup, they can tell that you use that substance because your body is still filtering out these tiny amounts that is still in your system. And so different substances and tests, I'm sure all have different lengths of time that it's still going to show up in your blood work, but I think they generally, I don't know exactly what drugs they drug test for. I'm sure that probably marijuana is in there because that would be the most prevalent, but I don't know if there are other ones that they're also checking for whenever they drug test. But I think they generally give like a month. They say that it could show up for a month after that you have done whatever illegal activity that you did that none of you guys would do, so we're not going to worry about this anyway. But it would still show up, so that's why it still does that, because you have that little bit left, right? Ibuprofen, I'm certain they're not drug testing for ibuprofen, but it would still be there to whatever extent. I don't know if they even have tests to test for this, but they could possibly tell if they wanted to. And I made up these percentages, so I don't know how much is actually left. But you guys see what is happening here. All right, I want to show you guys how to put this into, oh wait, we haven't even answered the question yet. Let's answer the question. The question asks us for a recursive formula. What were we doing each time to get to the next line? We were multiplying by 0.33, right? Times 0.33. Got us to the next line. All right, so if we multiply each time, that gets us down here. So I want to show you guys how we can put this into Google. Oh wait, no, sorry. So eager to show you the Google Sheet stuff. What is our recursive formula then? A sub n equals, we're just multiplying by 0.33 each time, so we'll have 0.33 times a sub n minus 1. That just means to get the next term, we take 0.33 and multiply by the term before it. The notation looks complicated. The idea is just that you're multiplying by 0.33 again and again and again. Okay? All right, so let's go to Google Sheets and pull up a fresh spreadsheet here, and I'm going to zoom in on mine so you guys can see what I'm doing here a little better. All right, so what we want to do first, I'm going to label this first column hours, and I'm going to label the second column milligrams of ibuprofen. So what I want to do here is I need to type in my hours. And so because this has to go in increments of 4 hours, I'm going to go 0, 4, 8. Okay. Now, I would like to see what's going to happen for like a week or something here. So I could just keep typing 12, 16, 20, and so on. So, is everybody here? Okay, here. Okay, so let me show you a shortcut that you can use here. If you highlight these numbers you have already put in, I've got 0, 4, 8. There should be a little blue box right here in the corner. If you put your cursor on that blue box, click and drag it down as far as you want, it's going to fill it in for you so you don't have to type it. It recognizes that pattern and repeats that pattern for you. So it would be okay to just keep typing 12, 16, 20, 24. But if I want to ask questions about what's going to happen like a week out, that's much quicker, right? So what we're going to do over here is we are going to go over here and we're going to type in 400 because that is our initial dose that we have. And so I could do it manually, like we were just doing on that table that I hand wrote. But that takes a while to do, and you got to type it all into the calculator. Your decimals are going to get long. So this is where our recursive formulas are going to come in. So you're going to click in that cell right there below 400, right? And we're going to type equals, okay? If you haven't dealt with spreadsheets much, anytime you're going to use a formula, you start the formula with equals. If you don't put the equals in, it doesn't recognize it as a formula. So I'm going to put equals, and then my formula was 0.33 times, and to do the times, you're just going to do Shift 8. You got to do that little star. It doesn't recognize parentheses as multiplication. You can use parentheses to group stuff together, but you still got to have that little star for multiplication there. So we got 0.33 times, and then this is where our A sub n minus 1 comes from. It's our term before it. So all you got to do is click up here on the term that was before it. And rather than using recursive notation, this is using spreadsheet notation, and it says B2 because that is the cell B2. Okay, so we got our formula ends. Everybody see that okay? That there's the end. Okay, we'll hit enter, and you can see it finds the answer that we needed to have. All right, so I want this to keep doing that over and over and over and over again. So if you click up here on the cell, it says 132 right here, but notice up here on this line that you can see the formula that you had right there. So you want to click just on this cell. You don't highlight cells like I did over here. Just on that single cell. You see your blue block down here in the corner again. And you're just going to drag it down however far you want to go. And if I scroll back up, you can see I'm getting all those same answers. It eventually starts saying 0 at 108 hours. Theoretically, it never got to 0. But the spreadsheet just can't do any more decimals than that. And in reality, I'm sure that whatever fraction of a milligram of ibuprofen you have here might as well be 0 for those purposes. But you should see these numbers. So, everybody check with your neighbors, see if they've got that to work. I want to come around and check and see if it's working for you guys. Anybody have trouble? Let me know. Okay, so, just a second, let me check and see if that. Check my voicemail here in a second. We'll finish the. Okay. All right. So, this particular problem we also could have just done with an exponential equation. We could have just set up 400 times 0.33 to the. Really, you need to do like 4x power because it's in terms of 4 hours. But we could use an exponential equation for that. But sometimes you may, have a headache and you take some ibuprofen and it goes away and then this happens. You don't take any more. But sometimes you need to continually keep taking the medicine, right? So, I'm sure ibuprofen has a warning that you're not supposed to take it over so many days. But like if you're running a fever and you're taking ibuprofen to bring it down, chances are you might need to keep taking it until you're starting to get over whatever you've got. So let's imagine that Tanya needs to continue taking 400 milligrams of ibuprofen every 4 hours in order to manage her pain. Her body is still metabolizing 67% of the medicine every 4 hours. Write a recursive formula that represents the amount of ibuprofen in Tanya's body at the end of each 4-hour period. So, for this, it's similar to what we start with. So we got hours and milligrams here. So we got 0, we got 400. Okay, so after 4 hours, she'd still use up 33%, or use up 67%, so she'd have 33% left. So she'd have that 132 left that she had before. But what is she going to do at 4 hours? Take another dose. So what are we going to have to do to this amount right here? Add 400. So now she's got 532. Okay? So at 8 hours, her body would use up 500, start with 532 and would use up 67%, 33% would remain. I'd get 175.56. Okay? So we'd have this amount left. But what's she going to do? Take 400 more. Right? So at 12 hours, right, we would have let's see, that's going to be 675.56. All right, so we take 675 and multiply it by 0.33. And that would give us 222.9349. It is. Let's fix that. All right. 575.56 times 0.33. There we go. That's better. 189.9348. Plus 400. So we got 589.9348. And you would keep doing this, right? Over and over and over and over again. So what are you seeing is happening to the amount of ibuprofen in her system over time? It's increasing. So before it only decreased because she wasn't taking anymore. Her body was just constantly. But we actually see it increasing here. What do you guys think is going to happen if she just keeps doing this? Overdose? You think it's going to like eventually get to like 1,000 and 2,000, a million? Okay. Let's see. All right. So let's write it because I want to know for like big numbers what happens. Because yeah, she's probably going to do this for like a couple days, and then her fever's going to break or whatever pain is going to go away, and then she's going to, quit taking it, and it's going to go back down, so she'll be all right. But if she's got a habit here, right? She's taking this all the time. I definitely want to see what's going to happen to her over time. All right. So let's write a recursive formula for this. A sub n equals. What are we doing each time as we go from one line to the next? We're doing two things. What did we do first? We're multiplying by 0.33. And then after we multiply by 0.33, what are we doing? We're adding 400. So this is a more complicated recursive formula. We're not just multiplying or just adding. We're multiplying and adding. What this does is it makes it where we cannot easily, anyway, write a equation for this, right? So we can't use an explicit for this, or at least I'm not really aware. There might be a way to do it, but I'm not sure. So let's go back over to our spreadsheet. Okay? Milligrams of ibuprofen I'm going to put every 4 hours. Well, let's do 400. I'm going to put 400 milligrams every 4 hours. So I'm just adding on to the spreadsheet I already have because it's the same situation, but a different dosage that we're using. So the hours is not going to change. I'm still going to have 0, 4, 8, 12, 16. That'll stay the same. So, and I still want to use 400 as my initial. But my formula this time, I'm going to put equals, and I'm going to use that recursive formula, so it's going to be 0.33 times, and instead of using a sub n minus 1 like we would for recursive notation, we're going to click up there on the line before it. This time it should say C2 if you've done it the same as I have. If you have already erased your old one, if you happen to do that, then you can just use B2. It's fine. And then we do plus 400. Hit enter. And you can see I get that same number that I had before. All right. And I want to see what happens over time. So I want to drag this all the way down. So you click on that box and you drag it down. Uh-oh. What happened? Oh, there it is. Okay. So here's what I'm getting. You guys check to see what yours looks like. Check your neighbors, see if they're getting the same numbers that I have up here. Do you think she's going to overdose? Okay, are her levels going up to like sky high? What's happening? They're evening out, right? So what we're seeing is like basically they're stopping here at 597.014, right? Technically, I think these are changing maybe like a little tiny bit. You see it goes from 2.3, 5.2, 5.3, 5.4. But you're leveling out. So what's happening is it's kind of like stabilizing the level of ibuprofen in her body. Now, this could still cause damage over time. If she did this for 5 years, she would probably have liver damage because of it, right? That's why it tells you on the bottle not to take it for more than this many days without seeing a physician, right? So in most cases, now if you have of course, if you have chronic terrible pain, they probably don't just give you ibuprofen for it, but they wouldn't want to keep you on something like this very long because it could cause damage to your body over time. But as far as overdose sort of levels, like immediate overdose sort of levels, you're not going to see that here, right? And as long as she only does this for a short period of time and then quits, then she'll be fine, right? For that, assuming she doesn't have any other issues. So this is really interesting because this is how basically all medicines work, but a lot of medicines, they'll give you they'll tell you they'll take a few days or weeks for it to build up in your system, right? So if particularly, I know that medicines that they give for ADHD and stuff like that, they'll say that it takes a little bit before you can tell if it's working because you've got to let that build in your system. So it's doing this over time. You're taking a little dose, and a little bit more, or you're not actually taking more, but there's more still in your body. So it's sort of building up in your system. And then it's going to sort of level out where you have those levels. They'll still fluctuate some through the day because we're not considering how much is in her system at 18 hours, right? But it's still going to be relatively constant day to day. So as long as you take your medicine like you're supposed to. So I think this is kind of interesting, how the numbers work out with this. And it's something you would really want to study in depth, say if you were coming out with a new drug, because you would need to study this in lots of different people. You would need to know correct doses for correct weight people. You would need to know, you don't want that level that it's leveling out at to be too high, because if it's too high, that might cause side effects that are bad or damage parts of your body. And you definitely don't want it too low, because if it's too low, then it's just not going to do anything. It's not going to work. I think this stuff is really cool. I would love to know someone who actually does some drug development, medical research sort of stuff to see what kind of stuff they do to what goes into all of that. But I don't know anybody. So if you guys know anyone that wants to be my friend that could tell me about these things, put us in touch here. But I think it's really cool stuff and important too. So let's still think about Tanya. She's really feeling bad, and she has decided that she now needs to take 800 milligrams of ibuprofen. So that's a double dose. That's 4 pills if you're just doing over-the-counter kind. Although, if you ever get prescription ibuprofen, it's 800 milligram. So doctors will sometimes prescribe this to you, even though I don't understand why they do prescription ibuprofen of 800 milligrams. I don't know why they don't just tell you to take 4 pills instead of 2. But because I know whenever I had my kids, they prescribed me the prescription ibuprofen. It's a giant pill, and it's 800 milligrams instead of taking But you could just take 4 of the regular little ones, and it would be the same. So I don't know why they do that. Other than they want to run it through insurance, I'm not sure.
I normally just take 4 regularly.
That is not medically advised.
Jace took 8 before baseball game.
That's a terrible idea.
Can almost certainly say that.
I'm not going to say I've never taken more than 2 at a time, but
After my knee surgery,
You do not-
I didn't want to take like the.
well, knee surgery is a
The
yeah,
painkillers you gave me, I didn't want to take them.
yeah. I think you should definitely
Because I couldn't drive.
be careful with
if I-
those.
So I was taking.
Yeah.
I get up every morning, take like 5 Advil before I got out of bed.
Yeah. For short periods of time, particularly with things like knee surgeries, like doctors will tell you to do that. Because for short periods of time, it will be okay. If you have taken more than 2 ibuprofen at a time, I am not medically advising you to do that, but I also don't want you to have worry a lot about it. Over time, it would definitely be a bad idea, and you would need to consult. Oh, good. His, Hunter's prompt was that you had to draw something about your hometown, so he did just draw the elk. Because we don't actually have elk here, but it's Elkin, so it works. It's cute. I have no idea how good the other kids look, but he did a good job. So I'm glad that he got to draw the picture in practice, guys. He had no idea what else to do, I'm sure. All right, so if you're going to take 800 milligrams, which, again, consult your physician before you make any medical decisions. I'm no expert on this. If you're going to take 800 milligrams, how is our equation going to change? Because let's just think about our equation and let's work with our formula. So, as far as our equation goes, we had a sub n equals 0.33 a sub n minus 1 plus 400. That's the one we just did, right? So, if we're changing it so that it is for the 800 milligrams she's taken every 4 hours, what's going to change about this equation? Yeah, instead of 400, we're going to make that 800. And then we have to change one more thing over here on our formula, right? If we want to do, so now we're going to do milligrams of ibuprofen plus 800 milligrams every 4 hours. All right, so what my formula needs to be different. What else needs to change? There's one more thing in my table that needs to change. How much is she taking in each dose? Double. So what do I need to have on my first line right here? It's going to be 800. All right. So I start with 800 instead of starting with 400. And then my equation is going to equal 0.33 times, just click on the one before it, plus 800. So it should look like this. It's our recursive formula. We're just using D2 instead of a sub n minus 1. And I'm going to click here. And now I'm going to drag this down. So the question asked about 24 hours, and so I can just use my table, or I could have figured it out otherwise. But my table tells me 1193.521. 1193.521 milligrams. Oh gracious, a week. How many hours is in a week? 7 times 24. 168. So, 168, if we look right here, it really doesn't make much of a difference because it's leveling out. 1194.02 or 030, I guess. 1194 will be close enough. About 1194 milligrams, which you were just about at the end of your 24-hour period. Again, please do not use this as official medical advice, but this is kind of what we would see happening roughly. So there are a lot of different things that this stuff applies to, which is kind of cool. All the different things that it can work with. So medicine is a big one. So you will see this in a lot of medical sort of context. It's really important to understand because particularly if you are dealing with more powerful substances. Ibuprofen, if you accidentally take a little bit too much, I don't know about James taking 8, that sounds like a terrible idea. Please do not do that. But if you take a little bit too much, probably your body's going to be able to compensate, assuming it's not all the time, assuming that you just took 3 or 4 once, or, I'm not going to give you medical advice there. Follow the label, please. But you'll probably be all right. But if we're dealing with really, really strong and powerful substances, then it's going to matter a lot more, right? I had to have like an outpatient procedure done, and the anesthesiologist came in to tell me like what he was going to give me and everything else because they had to put me to sleep. And he told me that they were going to give me whatever drug it was. He said that it was Michael Jackson's drug of choice, which is not a funny thing to say to someone who's about to be put to sleep because Michael Jackson died from taking too much of this particular drug. Now, it was kind of over time for him too, but still. I did not think it was funny. So everything went fine, and I woke back up. I don't like being put to sleep at all. But if you're an anesthesiologist, it really matters that you get it right because you can easily kill people with the drugs that you are giving them. And that is why anesthesiologists have to go to school for a very long time, and anesthesiologists get paid a lot of money because putting people to sleep is not something easy to do. And you must be very, 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 very careful with it. So the weight of the patient is really important. Making sure you've got the right concentrations of everything. If you give somebody too much of something, it's not going to be good. If you don't give somebody enough of something, they're going to wake up in the middle of a major surgery. That's not going to be good, although it's better than killing them with anesthesia, I guess. But either one's really bad. So I don't even like to think of being put to sleep or other people. I don't even like it. But I'm glad that we can do it because there's a lot of things we couldn't do if we couldn't do it. But it scares me, and I would not want to be an anesthesiologist. I could teach you how to do something wrong today. I could teach you everything about this lesson wrong. I could totally mess it up. And it would not be great. But you guys would probably all live the rest of your lives perfectly happy and live through that moment without any major issues. An anesthesiologist does not have that kind of room for error like I do. I could teach you this whole class wrong, and you'd probably be angry with me, and it wouldn't be good for your math career, but you would still be alive. So that's a lot of pressure. Anybody out there want to be an anesthesiologist? You do?
I was going to go for that, but I was like, it takes like 14 years. I was like, I might as well study to be like a nurse.
Right. Like not be the one ultimately responsible. Yeah, that would be. Yeah, I think I'd like that too. It takes a really long time in school, and yeah, yeah. They deserve the money that they make because maybe more because that's a crazy job. So, stuff like that can be, it can be minor, or it could be life or death anesthesia, or we could be talking about the fish pond. So, example 3, actually that's the second example 3, because I've labeled these incorrectly, because apparently I cannot count. But we'll have to change them all if I change that one, so I'm just going to leave it. So, population of fish in a pond decreases each month by 20%. The pond is restocked each month by adding 100 fish. If the initial population of fish is 250, write a recursive equation that gives the population of the fish pond over time. Okay? So this is also something really interesting, and something, if you're like a wildlife biologist that is studying populations of something in the wild, I doubt Jim's catfish pond is, writing recursive formulas to make sure they've got their catfish pond stocked well. But if you're like a biologist that's studying these sort of things, and you're looking at populations, and sometimes they'll adjust, like for hunting, they'll adjust like the limits that you can have, the number of tags that you can have for things, because they want hunters to kill more deer because there are too many in the population, or they want them to kill less because we definitely don't want to like hunt them out. So this could apply. We're going to look at the simplified version of fish pond, right? In this case, we start off with 250 fish. The population is going to decrease 20% per month from whatever that is. Fish dying of natural causes, maybe it's fishing where you can keep it, whatever is happening here. You got a natural decline in that population. So you're going to restock, which happens a lot. Some of the kids used to take field trips over to the hatchery that they have in that Devotion, like over there where the like Cap's Mill's not there anymore, but because the dam broke, but like Dobson sort of area. If you go back in there, there's like a hatchery. There's like a gate, and it's all like kind of mysterious. Like, it looks really fancy, but you can't get in there. So I think there's like some big houses or something up there. I don't even know. But there's lots of hatcheries where we just, it's like fish farm, and then we take them and we put them into the real pond, so that we have more fish in our pond. If 20% decrease, we need to ask ourselves what percent remains. So if it's a 20% decrease, what percent remains? 80, right? 20% are gone, 80% are still there. So our formula is going to look like this. We're going to have A sub n equals 0.80 times A sub n minus 1. So 80% of the ones that we had last month, they're still there. And then what are we doing at the end of that month? Adding 100. So that's our recursive formula. Okay? And we are going to use the spreadsheet for this and for all of these. And down there at the bottom, you can erase it out if you want. Or if you hit the little plus sign, it'll add a sheet. And it'll give you like a new sheet, but it won't get rid of the old one in case you think you might need to go back and look at it or something. So I'm going to do that here. So we're going to say that this is months, and this is fish. And months, I just want to go up 0, 1, 2, 3, 4. So whenever you're doing this, you can just highlight the first few. The program will recognize the formula for you. You can just drag it down here. And then how many fish are we supposed to start out with? 250. And our recursive formula goes here. So we got 0.8 times, just click on the cell above it, plus 100. Okay, check on your neighbor, make sure they've got There's, well, okay, here. All right. That tells us we'll have 300 fish. If I click on just that cell where I put my formula, drag it down, I'm going to get, looks like that's evening out pretty closely there. All right, the first question said population of fish after a year. What should I look at for that? 12, so I'll go to 12 months, and we got 482.82. Let's go ahead and just round that to the nearest whole fish, because we know in reality, so we'll go 483 fish. In reality, you can't have part of a fish. Not part of a live fish, anyway. And then in the long run, over time, it's kind of a vague problem, but what it means is like, what does it sort of even out at, right? And so what are we seeing the population even out at for this pond? 500. So it's basically 500 there that we see it evening out at. So about 500 fish. So if you were studying this, you would want to know, you know, what an appropriate amount of fish is for this particular area, if that is good or bad that you have 500 fish. You also can have invasive species where they just start taking over, and then that's not good because you get way too many fish. In that case, sometimes you can use like native species to combat invasive species, so it's got some cool stuff to learn about it. All right, questions? All right. Okay, let's drop to the application for a second. Let's go back to just like regular plain problems. Okay. Given the recursive formula, a sub n equals a sub n minus 1 plus 3n minus 1. If the first term is 2, find the next 4 terms in the sequence. So these are just like naked problems. When we had a state test, they used to ask us these questions, so I figured they want us to learn it, so we'll keep learning it for right now. It could have application, but I am sure that its application is going to be way beyond what we're going to be able to understand. So we're just going to learn how to do just the basics of this. So it tells me here the first term is 2. So if it says first term, make that a sub 1. Part of me wants to make it a sub 0. Really, honestly, it doesn't matter that much which one you call it. Actually, it doesn't matter on this because it has an n in the formula. But if it says first term, just make it a sub 1. I think what I've done on the questions on the quiz is I didn't say first term is 2. I said a sub 1 equals 2. So you know for sure it's a sub 1. All right, so if I know a sub 1, I now want to find a sub 2. Because the way recursive formulas work is you have to find the next number, and then the next number, and then the next number. You can't just skip to the 5th term. You got to find 2, 3, 4, 5. You've got to find all the terms in a row. So, what this means right here whenever I see this is that n equals 2, right? My n equals 2. So if I plug in 2 for n into this equation, okay, it's going to look like this. A sub 2 minus 1 plus 3 times 2 minus 1. So all I'm doing there is I'm taking that 2 that I see here, and I'm plugging it in those places where I had n's in the original formula. Okay. So what is 2 minus 1 right here? It's just going to be 1, right? So we got a sub 1 plus, if we can go ahead and multiply these together, we got 6 minus 1. What is a sub 1? it's 2, right? So I can take the a sub 1 right here that I knew was 2. I can put it right here for that. So I've got 2 plus 6 minus 1, which is going to give us 8 minus 1 will give us 7. So a sub 2 equals 7. This asks us for the next 4 in the sequence, so I know I've got 2. I just found 7 is the next number. Now I need the next number. Next 4. We might quit early. We might not do all 4. So if I want to find a sub 3, now n equals 3. Alright, so that means I've got a sub 3 minus 1 plus 3 times 3 minus 1. And 3 minus 1 is 2, so that's a sub 2 plus 9 minus 1. What was a sub 2? It was 7. So we do 7 plus 9 minus 1. So that's going to give me 16 minus 1. I'll get 15. So a sub 3 is 15. So the third number in the sequence is 15. Okay. If I want to find the next one, a sub 4 would be, now, you guys see a pattern happening here? What's that a sub n minus 1? It's just, in this case, it's just going to be the term before it, right? Because if I do 3 minus 1, it gave me 2. This time I'm going to do 4 minus 1, it'll give me 3, right? So if you need to, you can write it out like I've done here every time. But I'm recognizing that just a sub n minus 1 just is the term before it. So this is going to be a sub 3, which is 15, plus 3 times n, which for this one is 4, minus 1. So I would get 15 plus 12 minus 1, so that's 27 minus 1 will give me 26. So a sub 4 is 26. I guess we'll go ahead and find the last one. For the last one, a sub 5 would be the a sub n minus 1 in my formula. It's just the term that came before this one, so that'd be 26 plus 3 times n is 5, right here minus 1, so 26 plus 15 minus 1, so 41 minus 1, I'll get 40 for that. So that's what we would end up for our sequence. Okay, questions there? Okay. Here's another really good application for recursive formulas. This one gives us our recursive formula. A sub n equals 1.004 a sub n minus 1 minus 950. Gives the amount of money that a person still owes on their mortgage if they initially owed $120,000. Okay, we want to know how much they owe after a year, 5 years, and how long it's going to take them to pay off their loan. Okay, so this is the way loans work. So whenever you go take out a loan on anything, they're going to charge you interest most of the time, unless you happen to get a 0% interest rate, which is not going to happen on a house or something like that, but could happen on some other stuff. But you're going to get an interest rate. The interest rate, they're going to take it, they're going to divide it by 12 for the months, and they're going to charge you that amount of interest. So like I've got 0.004, which is 0.4%. That doesn't mean that you're getting 0.4% interest rate, because that would be like crazy good, right? That's per month. So if you multiply by 12, just to get an idea, like the realisticness of this. That'd be 4.8% per year. Now, you don't actually need to use that for this problem. I just want some reference of like what's happening here. So, what happens for this? Let's start us anew. Is that we've got months, and we're going to start at 0, 1, 2, 3, and we're going to drag it down pretty far because it takes a long time to pay off a house. And amount owed. And so you start off and you have borrowed $120,000. Okay. So, what happens is they're going to take that amount that you owed. I'm going to do it on the calculator just so you can see. They take the $120,000 and they're going to charge you your interest. So if I multiply it by 1.004, like that, that means they're adding interest for this month. They added $480 to what you owe. Right? So you are going to now start off owing them $120,000. Now you owe them $120,480. They're going to set your monthly payment at something. It's going to be definitely over $480 because otherwise you'll never pay this loan off. It'll just skyrocket and they won't let that happen. Right? So what is the payment for this? Looking at that equation, how much are they paying each month? $950. So they're paying $950. So then you subtract the $950, and now that's how much you owe the next month. And then they would take that and they would multiply it by 1.004, and they'd subtract 950. Hello? Yes. You're right. Lee, you are leaving. Let me give you a worksheet. And so if we put in our formula equals 1.004 times line before it minus 950. So like what's happening here is you're adding 2. You got the 1.004 adds 2. You add the interest and then you subtract your payment. And so if we take this and we drag it down. Okay, good. We got to negatives here, so we don't really need that because once you get to negatives, you've paid your loan off there. So you want to make sure you go down at least far enough to start hitting the negative values because we want to know when we pay this loan off. So here's the discouraging part for those of you who have not bought your own home yet. You have taken out this loan in the first year. You still owe $114,234.25. Now you paid $950 times 12 months. You paid $11,400. But how much did your amount you owe go down? Less than $6,000. All right, more than half of what you paid was just interest to the bank. So after 5 years, so 5 years is going to be 60 months. We are at $88,199.72. So you're starting to make some progress on it at 5 years. But at the beginning, you have to pay so much in interest because they're figuring interest off of the $120,000 that you're paying so much in interest it feels like you're not paying anything off much. When you get towards the end, you're not paying as much interest. You're paying more of the principal, so you're paying bigger chunks of the loan. That's why the faster you pay this off, the the less you're going to have to pay in interest. And so if we look at how long they're going to have to pay, let's go all the way down here till we start hitting negatives. 177 months. Which, if I ask you how long it takes you, is going to take you to pay off your house, and you tell me in months, I'm going to think you're weird, right? If we divide that by 12, it's 14.75 years. Which is actually really good, because they'll do up to a 30-year loan. So, if you pay your house off in 15 years, that's pretty good. Also, here's the really discouraging part. 177 times 950. You paid $168,150 for that house. If you had had cash, you would have only had to pay $120,000. You paid $48,150 just to the bank, so they'll let you use their money. That's a lot of money. And they paid their house off pretty fast. If you get a 30-year loan, it almost doubles the price of your house a lot of times. So, there's a taste of adulthood for you. Mortgages. Super fun. This worksheet is your homework. The key should be posted so you can check your work. The first of it is like the stuff we did on Friday.